If I look at the next one, it says an investment of $1,000 is earning 6% APR compounded monthly. And keep in mind, I've got APR here, and it's compounded monthly. And that's very important because I got to make sure all these units match. And I want to know what the account balance is going to be in 10 years. So my generic form of this equation is y equals a times 1 plus r raised to the t. And so when I do this, I want to make sure all my values, all my units match. So the a value is the 1,000. 1 plus. Right here, the 6% APR, that's an annual percentage rate, but it's compounded monthly. So I need to change that to a monthly rate. So if it's 6% per year, and I want to know how much it is per month, I've got to divide that by 12. And so when I do that, I find out that it's 0.5% per month. And so when I plug this into my formula, I want to write this as a decimal. Well, 0.5% as a decimal is 0.005. Okay? So my time needs to be in months. Okay? So that 10 years is not going to quite hack it. I've got to change that to months. That's 120 months. All right? So again, got to make sure those units match. All right? Now everything is in terms of months. My rate is in terms of months. My time is in terms of months. And now I can go ahead and plug this into my calculator. Again, follow order of operations here. So I do the 1 plus the 0.005 and then raise that to the 120th power and then multiply it by the 1,000. And I'm going to find out that I have $1,819 and approximately 40 cents is what this ends up rounding to. Okay? So again, make sure those units match. If I look at the next one, it says an investment of $1,000 is earning 6% APR compounded continuously. So again, this is 6% APR compounded continuously now. Makes this thing just a little bit easier. And it makes it easier because I can use my continuous formula. And my continuous formula is this one, a of t equals a times e to the kt. So what I have here is my initial amount, which is the 1,000, times e to the k, which is the rate, which I'm going to write as a decimal, is a 0.06, multiplied by time, which is in years. And when we're dealing with money here, this one is kind of automatically in years for us, so I don't have to adjust the rates. I can put the time in years, and I can put the percent in just the way it is. I have to make sure that the values match between the percent and the time, but I don't have another time piece that I need to deal with here. So now I just need to plug this in. So I plug this into my calculator. Again, following order of operations, using that e raised to a power button on my calculator. And it looks like I get approximately $1,822.12. So I make a little bit more, which makes sense because I'm compounding it more often. Okay? And if I look at more and more values of this thing and take this out to further and further places in terms of years, I'll see a larger and larger discrepancy between these two values. Okay? For this one, it says a new car costs $35,000 and depreciates at a rate of 26% per year. How much will the car be worth in 5 years? This one is exponential decay, and it's my standard model for decay. So really, it's just like the growth model that I used 2 problems ago, but it's a minus sign now. I plug in my initial amount, which is the $35,000, 1 minus the 0.26, raised to the t, which is now the 5, and it's just a matter of plugging this into my calculator. And once again, I want to make sure I follow those order of operations. Just be careful with that. That's where the mistakes are going to come in. You got to make sure you do that subtraction first, then raise to the power, then multiply by the 35,000. It looks like about $7,766.52. Okay? For this one, it asked me to write each of these in standard form. So the first one, right away, it's important to identify what kind of conic section I'm dealing with. Since I've got coefficients here in front of the squared terms that are exactly the same, it means I'm dealing with a circle here. So I'm going to, off to the side, just remind myself that this is a circle. So I need the standard form for a circle. So now I'm just going to move some things around. I'm going to subtract the 6 to create a little bit of space. So I've got x squared plus 8x with a little space plus y squared plus 6y with a little bit of space equals 11. And now from here, I just need to fill in the blanks, complete it in square. B divided by 2 and square it, that's going to give me a plus 16. B divided by 2 and square it, that gives me a plus 9. Whatever I do to one side, I also have to do to the other side. So I make sure I add those values to the other side. This factors into an x plus 4 squared. The y values factor into a y plus 3 squared. And when I add all this up over here, it looks like it gives me a 36. And that's it. That's the equation of a circle. I don't need to bother dividing by the 36 because I know this one's a circle, and it's just equal to r squared. The next one, I start off the same way. I'm going to identify the conic section. I notice that the coefficients are not exactly the same, but they at least have the same sign, which means that I am dealing with an ellipse this time. So since I'm dealing with an ellipse, I'm going to start off the same way. And things will become slightly different as I go. So I've got a 5x squared plus 30x, a little space, plus 4y squared minus the 16y with a little space, equals a negative 1. And now from here, I can't do b divided by 2 and square it just yet. I've got to factor out these a values because I can't complete the square unless I have a 1 in front of the x squared. So when I do that, let me skip this over just a little bit to give myself a little more space. I factor out that 5. That gives me a plus 6x with a little space. Here I factor out the 4. And now I do b divided by 2 and square it. That gives me a plus 9. B divided by 2 and square it gives me a plus 4. That 9, it's a 9 inside parentheses, but it's actually a 5 times 9 to this entire side of the equation. And so even though I added a 9 inside the parentheses, what I really added to that entire side was a 45. So I need to add a 45 to the other side. Likewise, that's not just a 4. It's a 4 times 4. So that's a 16. It might be a 4 in the parentheses, but it's 16 to the entire side. And I got to make sure I add the same thing to each side. So now this factors into the x plus 3 squared. This guy factors into the y minus 2 squared. Over here, I just add all these up. It looks like that's going to give me a 60. And now since this is an ellipse, I do have to divide by the 60 because this whole thing should be equal to 1. And now it's just reducing each of these fractions. When I reduce the 5 and the 60, that reduces to a 1 over 12, so I get x plus 3 squared over 12. When I reduce the 4 and the 60, that gives me a 1 over 15. All right, that is a 15 equals 1. And now there's one last thing that I need to do with this guy. Because this is an ellipse, technically, the larger denominator has to be written first. And so I have to switch these two fractions around. So when I do that, I'm going to rewrite this as y minus 2 squared over 15 plus x plus 3 squared over 12 equals 1. Now it's written completely in my standard form. Okay? Move a little space for my next example here. All right. If I take a look at the next one, right away looking at these terms, I would maybe think that this thing is an ellipse, but keep in mind that these are kind of in the wrong places as I'm starting out. So maybe I'll scoot some of these things around. I'll bring this minus 10y squared over to the other side, and maybe the minus 40 over to the other y over to the other side. And when I do that, when I put it kind of in the same format that the rest of these were in, maybe I'll reorganize just a little bit. That format feels a little bit more familiar. Now when I look at this thing, the coefficients have different signs here and here, the 12 and the negative 10, which means what I'm really dealing with here is a hyperbola. And if I had thought this was an ellipse at first, I'd still complete the square and put it in standard form the same way, and I'd find out very quickly that I've got a minus sign in between. But now I'll go through that same process. I'm going to subtract this 32 from each side. I'm going to go ahead and factor the 12 out. And the negative 10 out. And just be careful with your signs here. I'm factoring in negative 10, which gives me a positive or a plus 4y here. And now I can complete the square. B divided by 2 and square root is 16. Here, b divided by 2 and square root is a 4. And once again, keep in mind that that's not just a 16. It's a 16 times 12. So what I really added was a 192. This one, it's not just a 4. It's a 4 times negative 10. So what I really did was add a negative 40 or subtract 40. And again, be careful with your signs there. Can make these just a little bit tricky. So now I've got 12. That's an x squared minus 8x. Oh, sorry, let me factor this thing. What am I doing? So I've got 12. That's going to be an x minus 4 squared. This one's going to be a y plus 2 squared. Over here, when it's all said and done, I add all this together. That gives me a 120. And now I've got to divide each side by that 120. When I do that, I'm going to bring it over here. The 12 and the 120 reduce to a 1 over 10. The negative 10 and the 120 give me a negative, and that's how I can tell that this thing is absolutely a hyperbola. And those are going to reduce to a 1 and a 12. And with the hyperbola, it doesn't matter if the second denominator is larger. What matters is where that minus sign is. Okay? In these next couple, I just want to identify the type of conic section. I've done that a little bit already. But again, I've got two squared terms, so it's not a parabola. And the coefficients have opposite signs, which means this thing is a hyperbola. Okay, that's the giveaway. The next one, I look at the values. I've got two squared terms. The coefficients are different numbers, but they have the same sign, which means this thing is an ellipse. The next one, I've got two squared terms again, and the coefficients of those squared terms are exactly the same, the 4s, which means this thing is a circle. And now the last one of these four, obviously there's only one squared term, kind of sticks out like a sore thumb. That one's my parabola, okay, because there's only one squared term. All right?